We do part A, graphing polynomial functions. This portion is going to be from lesson 3.5. Describe the key attributes of the polynomial function f of x equals negative 7x times the quantity x minus 3 times the quantity 5x plus 1 squared. So first question is asking for your degree. The definition of degree is your highest exponent. So when it's in standard form, it's easiest to see because it's already in order from highest to lowest. However, this polynomial is in a different form that we call factored form. And when you want to find the degree of your factored form, you're going to look at the individual multiplicities for each of those factors. So the first factor given to you is negative 7x, written as a GCF. But because that GCF does have an x variable, you do want to include its exponent, which is a little hidden 1 there. So we say that that has a multiplicity of 1. Your second factor has x minus 3, and its multiplicity is also a 1. And then the last factor is 5x plus 1, which that one has a multiplicity of 2. So to add all those up will give us our degree. So 1 plus 1 plus 2 is going to be a degree of 4. Now remember, the degree is going to tell us whether we're going to have odd or even in behavior trends. So because 4 is an even number, we know that we're going to have an in behavior trend that is needed to represent that both of those ends are either pointing up towards positive infinity or down towards negative infinity. To decide that, we're going to use our leading coefficient. So with this factored form, with that GCF in the front, it is in proper order, and our leading coefficient is going to be a negative 7. Your leading coefficient is going to tell us whether it's going to have positive or negative. And so with this being a negative 7, we're going to say that we have a negative even trend, which means both of the ends, left and right, will point towards negative infinity. To find your y-intercept, you need to remember the definition of the ordered pair for a y-intercept, which is that your x value will always be a 0, and then you just need to find what that y value is. So you can graph it, but it is asking for you to show the work. No matter what form your polynomial is in, to find a y-intercept, you're simply going to substitute 0 in place of every x. So I'm going to rewrite that original f of x, but every time I see an x, I'm going to remove it and set up parentheses for substitution so that I can go ahead and plug in that 0 in its place. Next up is x minus 3. And so I'm going to remove that x, keep the minus 3, and plug in a 0 in its place. And the same thing with the 5x plus 1. Going to remove that x and plug in the 0. From there, you will either do it in your head or you can type it in all at once. And whatever you get back is going to be your output, which is another way of saying your y value. And so just double check and make sure it looks the way it's supposed to have been written. So every x has been removed and replaced with a 0. When we hit enter, we get a 0 back. And so this y-intercept is at 0, 0. So we can actually go ahead and graph that here, and we'll keep it in purple. This is my y-intercept. All right, next up is your zeros, and then a workspace is provided. So zeros are another word for your x-intercepts. To calculate your x-intercepts, you're going to take each of those factors and set them equal to 0. So our first factor, set it equal to 0, and then we're going to solve. Then our second factor, set that equal to 0 and solve. And then I'm just going to squeeze this in down here at the little bottom, 5x plus 1, and set that equal to 0. So to start solving, you have to isolate your variables. A negative 7x implies a multiplication, so you do the inverse and divide. Well, 0 divided by anything is going to be 0. And they want us to write our zeros as ordered pairs. x minus 3 to isolate, I would add 3 to both sides. And so for this one, we would have an x-intercept at 3, written as the ordered pair 3, 0. And I'm going to scoot this up just a little bit here and make myself some room. And to isolate this variable, we do have 2 steps. So we want to subtract that 1 first. And then when we divide by 5, we would get a fraction. You always want to do your fractions in simplest form, no decimals, please. So negative 1 over 5, if you don't already know, is simplified because they are both prime numbers. So we would have the ordered pair negative 5, 0. For the multiplicities of those zeros, you're going to go back to those original factors, and we're going to say whether they are odd or even. So my 0, 0 is in pink, and it connects to my original factor that is in pink, which is the negative 7x. And we said that the exponent there is a 1, so its multiplicity is going to be odd because 1 is an odd number. For our ordered pair 3, 0, that came from this portion, which our multiplicity there is a 1, and 1 is still an odd number. And then our negative 1 over 5, 0 came from this factor, and you can see that your multiplicity there is a 2, and so that is going to be called an even multiplicity. From there, you will sketch those zeros. And so we have 0, 0 already done. So I'm just going to kind of go over it in pink just to show that it is there. And then I'm going to need a 3. And so count 3 to the right. And I'm going to need a negative 1 over 5. And so that's going to be estimated just somewhere between there. It doesn't have to be perfect, but we do need to see a little bit to understand that you know where those placements are supposed to be. All right, from there we have to place our definition of that negative even. We said even meant pointing in the same direction, and specifically being a negative even, both of those ends will be pointing down towards negative infinity. And so we need to figure out what is actually happening there. Now, with those odds, we need to remember that when your 0 has an odd multiplicity, it's going to pass through. And when it has an even multiplicity, it's going to bounce back to the same side. So starting from my left here, the first 0 I would hit is negative 1 over 5. We said that negative 1 over 5 has an even multiplicity. So as I start to draw, I'm not going to pass through to the opposite side. I have to do what evens do, and I'm going to point back into the same direction. From there, I need to figure out how am I going to get back to that 0, 0. So we're going to do a very sharp turn. And for our 0, 0, we said that 0, 0 was odd. And so that means it's going to pass through 0, 0 to the opposite side like odds do. And then we're going to have to turn back. And next to 3, we also have odd, and so we're going to pass through and keep going to that other side. So one more time, starting from the left, always left to right in the direction that you read. We're going to have an even behavior and bounce back to the same side. Turn and pass through, and then turn and pass through one more time. And so, of course, you can graph it and see if it's looking the way it needs to. So we can type in that negative 7x, that x minus 3, and the 5x plus 1. And then you can kind of check. Right now you can't really see. You can zoom and see if you can find a zoom that is going to kind of show you that overall shape. But sometimes we just don't get lucky about what's going on there. And so we can't always depend on that. With these handheld calculators, they do have some limitations, so we need to know our definitions. All right, the last part is going to be our end behavior statements. And so you do an end behavior statement for the left side, and then you do an end behavior statement for the right side. So it's sort of a fill in the blank template. As x approaches something, your y's, which we write as f of x, are going to approach something as well. And then you double that for the right side. Now for your left, anytime we're going to the left, whether we're going slowly or very sharply to the left, your x values moving to the left keep getting more negative and more negative. So we say that that is called a negative infinity. As x approaches negative infinity, something's going to happen. On the right side, no matter what, your x's moving to the right will be getting more and more positive, and so we say that that is a positive infinity. So those two will not change. Anytime you do left, x approaches negative. Anytime you go to the right, x approaches positive. What you need to focus on is what is actually happening at those ends. So I need to fill in this spot as well as this spot. So let's look at our left side here and look at what our y's are doing. Since that arrow is pointing down, our y values are heading towards negatives. And so we're going to say that the f of x approaches negative infinity. On that right side, your y's are also pointing down towards negative infinity. Now, they do not always match. They will match for the evens, but they will not match for the odds. So just make sure that you take your time to process through what is happening at those ends on the left side and on the right side.